Today we are here to give a presentation on analysis on stream cipher based on the block cipher operation. Over the years, many ciphers were developed. There are block and stream ciphers for all kinds of applications. However, we need to guarantee the security of those ciphers. Then, we developed different attacks to test the residence of our ciphers. In this work, we will present the constitution of block cipher and stream ciphers. We will show the difference between them and discuss about the most important aspects, including CFB, OIB, CTR, and AEGIS for stream ciphers. We will present the most important work in this area, explain the attack, and give an example of applications.
I'm Jianyu Li. First, I introduce how the CFB works. The CFB will encrypt the initialization vector and then it will XOR with the plaintext block to get the ciphertext. The ciphertext can be decrypted to obtain plaintext using the reverse process. We can observe that in the decryption process, after encrypting the ciphertext block and XOR with the previous ciphertext block, then the plaintext is obtained. So, this mode has the probability of having replay attack. Assume that the sender sent 4 blocks, where the attacker saved the last 3 blocks, block 2, 3, 4. Suppose that the sender had sent 4 more blocks and the encryption key is unchanged. The attacker replaces the last 3 blocks of today with the previously saved block. After the receiver receives the 4 blocks, what happens when the decryption operation is performed? The decryption of block 2 will definitely fail, because the decryption of block 2 depends on the ciphertext of block 1, but the ciphertext of block 1 has changed. Block 2 necessarily fails. The decryption of block 3 and block 4 will succeed. It's also successful to decrypt into the previously saved plaintext, because the decryption of block 3 depends on the ciphertext of block 2. Since it has been changed, there is no change at all, and the encryption key is unchanged. So the natural decryption is successful. The same is true for block 4. The attacker successfully merged the previous message into new message without correcting the password, and the block 2 area is a communication area, or is it caused by human attacks? The receiver is unable to make a judgment. So at this point, the replay attack for CFB mode is complete.
Next, I will introduce the output feedback part. Algorithms that work in the OFB mode create key stream bits that are used for encryption subsequent data blocks. In this regard, the way of working of the block cipher becomes similar to the way of working a typical stream cipher. If one bit of a plaintext or ciphertext message is damaged, for example because of a transmission error, only one corresponding ciphertext or respectively plaintext bit is damaged as well. The biggest drawback of OFB is that the repetition of encrypting the initialization vector may produce the same state that has occurred before. It is an unlikely situation, but in such a case, the plaintext will start to be encrypted by the same data as previously. In the OFB mode, keystream bits are created regardless of content of encrypting data blocks. Next, this is the process of encryption and decryption. As we can see, the data we have are key bit key, K, N bit IV, and R bit plaintext blocks such as x1, x2 until xn. According to the process, it will produce R-bit ciphertext blocks such as C1, C2 until Cn. And it can be also decrypted to recover plaintext by using this for loop. Then I will mainly introduce the fault attack. The fault attack is a powerful cryptanalytic tool. It is widely applied in crypto systems, which are not vulnerable to direct attack. It is easy to find examples of fault attacks in block ciphers, but the first application of this attack in stream cipher was developed by Hosh and Shamir. In this attack, the attacker can apply some bit flipping force to either the RAM or the internal register of the cryptographic device. However, it has only a partial control over their numbers, location, and timing. This mode tries to reflect a situation in which the attacker has a position of the physical device, and the faults are transient rather than permanent. A good work in this area was developed by Boranchi and other people. They talked about this technique and where it can be applied. In their work has example using stream cipher and block ciphers. That's all for the OFB part.
My job is to analyze the CTR mode, which is one of the mode of operation of block ciphers. It was introduced by Whitfield Diffie and Martin Halver in 1979. It is one of the most popular block cipher mode of operations. It converts block cipher into stream cipher. CTR encryption. Encryption is done in many blocks according to number of blocks of plain text. A key and the counter value is used. Counter includes some nonce value to make it more unique and random. Now the counter value gets incremented by each block, and the key and the counter value gets encrypted to produce some random encrypted value. Encryption algorithm could be DES or AES. AES is generally used as it is more secure. In the last part, the plain text block is XORed with the random encrypted value to produce ciphertext. CTR decryption. Decryption is same, but the last part is different as compared to encryption. Ciphertext is XORed with the random encrypted value to get plain text. Advantages. There are many advantages, and I feature some of the most relevant to this topic. CTR model is fully parallelizable. That means block 1 and block 2 of plain text gets encrypted parallelly. The ciphertext is of the same length as the plain text, so no bits are wasted. Usage of XOR function makes it simple and easy to implement and gives secrecy if there is no repetition in key and the initial vector. It is fast and generally secure because of the XOR functionality. Useful in hard disk encryption, where the bulk of data needs to be encrypted fastly. Both encryption and decryption process are same, so decryption block does not need to be implemented. Successful in streaming data. CTR is one of the best choice for streaming data, as CTR is parallelizable. It is fast, could run on multi-core parallelly. The decryption and encryption circuit are same, which makes it implementation easier. Encryption can be done in advance, that is pre-process, which further increases the speed of operation. No bits are wasted when the ciphertext is produced. XOR implementation is generally fast, so hardware can do this operation without any large delay, which is suitable for framing data. On CTR, I listed some of the most common attacks. First, reuses of counter and nonce value, which could lead to replay attacks. Similar key usage is also a threat to security of the CTR. In the case of DS, initial counter value are of 64 bits, so birthday paradox and collision chances are there. If there is small distance, which is Hamming distance between the counter, then it could lead to differential.
Okay, let's talk about AEGIS part. AEGIS was introduced in 2013 in CISA competition. It's a very clever and special cipher because it not only provides confidentiality but also authentication. AEGIS was based on AES encryption. There are 3 types of AEGIS which contain 5, 6, 8 round encryption in each state. Because of its special function, it's very suitable for network packet. Let's use the AEGIS 128 to show how it works. Firstly, we should calculate the initial vector using the keys and initial vectors. And we should calculate the intermediate values, which is used by the last state of the intermediate values using the AES round encryption. Here is the work graph. And the the last encryption of this in this cipher is using the plain text, the intermediate values, using the XOR operation and the AND operation to calculate the cipher text. The decryption is just the same. The AEGIS implementation of the authentication is used the text, which is the part of the intermediate values using the XOR operation. Let's talk about AEGIS attack analysis. Firstly, initial vector we use the attack. Initial vector is very important in a block cipher operation. So if the initial vector are reused, some information will be get by the attacker. My report will concentrate on this part, and I will divide it to three parts: the chosen ciphertext attack, the chosen plaintext attack, and the pair of the initial vector and keys attack. The other attack type is a statistical attack, and actually AEGIS is very strong in this stage because the AEGIS has the AND operation in encryption, so the traditional linear attack analysis cannot work. So in this part, the long linear attack should be considered. At last, I will talk about the application of the AEGIS. The AEGIS was very fast, and is you can see in the form the AEGIS 256 as quickly as the AEGIS CTR using the AES 128 encryption. So in my report, there are some applications. I will show some implications in our life.